Thanks, Günther, for the introduction. I will give you some more information about me and why I'm speaking about this topic. The topic is, Steve would say, housekeeping. It's not that I'm talking about how software architectures work, because it's more or less how we can harmonize the models and the terminology. And I've used CAN by accident because I have some knowledge about CAN. So myself, I'm an electronic engineer, and I'm also a technical journalist since more than 45 years. This is the reason why I'm talking about this, and I was asked by the AUTOSAR organization to talk a little bit about how we can harmonize terminology, because terminology is something, if you're a technical editor, then you know about that for much more. I initiated also the non-profit CiA organization. We are a partner of AUTOSAR now, and we have congratulations for the 20 years of AUTOSAR. We are 1992. This means we are 31 years, a little bit older. We have more than 700 members. And I'm also a convener of different working groups in ISO, in particular for in-vehicle networks. So this is why I have some knowledge about CAN and other network technologies. Also the network applications. I'm also then participating in different ISO groups and IEC groups in DIN, the German standardization body, and in the SAE. Just have a short look back to history of standardization. You see that the first standardization was done in China. And this is a long time ago. The first Chinese emperor has standardized characters, currency, physical units, very important, and axle width of carriages, and this gives him the advantage for military logistics, and so he was then the emperor of China. Today it looks a little bit more complicated. We have now 3 international standardization bodies making standards. That's the ITU, was established in 1865. And then comes later the IEC, and the last one is the ISO. These are 3 organizations, but that's not the entire view. We have additionally European counterparts, the CENELEC and CEN, established after the Second World War. And to all of these international standardization bodies, they're contributing the national standardization bodies. And this is a long list. I have just mentioned a few of them, from China, Japan, Germany, America, and so on, and Sweden, not to forget. Also, that is not the entire picture for the automotive industry, where we develop specifications. There are also some national or regional automotive industry consortia, which contribute directly or indirectly to the international standards. CiA is a European association, and then you see Qatar, JASPAR, JSAE, SAE, VDA, and so on. This is not the complete picture. There are also some dedicated in-vehicle network industry consortia. We heard about this morning about the FlexRay consortia, but the FlexRay consortia doesn't exist anymore. LIN consortia doesn't exist anymore. CiA is still existing, and Monster Corporation is existing, and Open Alliance is dealing with the automotive Ethernet specifications. But even that is not the complete thing. You see that AUTOSAR, we learned this morning that Covesa, Eclipse, and Sophie and others also contributing. If you're missing ASAM, this was intended because there's an alphabetic order, and ASAM would be then in the first place, and it would be polite that AUTOSAR is in the first place. You see that all organizations develop by some means standards, or they make first the code and then the specifications, doesn't matter. At the end, there is somewhere a standard or specification. This is like in human communication. We have a lot of languages, and we have, so to say, the Babylonian language confusion, because the deliverables from all the different standardization bodies and industry consortia are written by different editing rules. And they use terms which are not harmonized. even not within one organization. This makes a lot of headaches for young engineers if they read documents from different associations. And the models which we're using for communication, for example, are also not harmonized, and we have not defined or specified or described the relations between the different models. So the takeaway is this can lead to misunderstanding and misinterpretations, and we suffer all. However, there are some ideas how you can overcome this. IEC and ISO, they have worked together, and they detected this problem a long time ago, and they have developed, so to say, some harmonized drafting rules. This is nice. If you read an IEC standard or an ISO standard, they have the same structure, they have the same rules, how to edit those documents. Even the template is the same. So this would be interesting if we could use this also for other organizations and they adapt this. I don't say they have to copy it one by one, but you should, in minimum, adapt the most important thing. CiA has done so. We write all our documents with the same template, just another cover sheet. So when we submit something to ISO or IEC, it's very simple. We just take the Word document, make another cover sheet, and it's an ISO or IEC standard. So I recommend that we all do and look how far we can go in all of these consortia to adapt that what has been developed and continuously is updated. The last update from this directives is from the year 2022. One of the most challenging things is that we are using different provisions for or expressions for provisions. So if we all have in our documents requirements, recommendations, permissions, possibilities and capabilities, and external constraints. ISO and IC have harmonized the allowed verbal forms for that. So a requirement should be indicated by shall or by shall not. Recommendations should be given by the word should or should not, permissions by may or may not, possibilities and capabilities by can or cannot. And for external constraints, we're using must or must not. One of the challenges is if you are not thinking in English language like me. I'm a German, and my mother tongue is not English. I have some difficulties to use can and may, and all my colleagues also. And most of these standards are supported or driven by German experts. They mix up can and may. And this has some difficulties if you have on the wrong place can and may. So we should stay with these kind of expressions. And if we do this over all specifications which we release from whomever, then we avoid some misunderstandings and misinterpretations. I came just from an SIE meeting earlier this week, and they have said always, because I'm claiming always on the can and may, why you don't read the documents earlier? Then we would avoid a lot of last-minute changes. Okay, we do so. I'm now reading a lot of these SIE standards in advance so that they can adapt this correctly, and they are native speakers. There's also a hidden gem from ISO, and this is called ISO house style. And after 15 years working with ISO, I detected this. Very deep on the website, there was this nice document which explained all that what left open in the directives, or give me some examples in detail. So I can recommend to read this document and to adapt this for each of the consortia. We have done this in CiA, and we have done our own house style document because we're using, instead of ISO and IEC, not the British English, but the American English. This is the only difference which we have adapted. All the others we have adapted mainly. There's also, from ISO and IEC, unfortunately these are two different databases for term definitions. And ISO provides the online browsing platform OBP, which contains term definitions and other useful information. For example, graphical symbols and so on and so on. So yesterday we discussed also then from the SAE if we can call it kbps, but this is wrong. This is kilobit per second, and sometimes they write it with a capital K, but this means 1024 officially. But they mix this up, and young engineers could be confused on that. IC also provides such a vocabulary. It's called Electropedia. And CiA, we have also our glossary of terms where we define those terms. And we have, in addition, a dictionary where we describe those terms. Also, there's a difference between a definition and a description. A definition is a statement that explains the meaning of a word or term. A description is a statement giving the characteristics of something or something that tells you what something is like. So also don't mix up definitions and descriptions. Sometimes I've seen specifications where they claim to provide definitions, but they are descriptions. Let's go for one example, because I heard this morning and I was aware that this vehicle signal specification. What means signal? If you look to the Oxford Learner's Dictionary, and I have to do so because I'm not a native speaker, I always look to that what is commonly agreed. A signal is a movement or sound that you make to give somebody information, instructions, or a warning, etc. Is this what we are doing? Just answer it by yourself. And then we're looking to IC. IC has, in the database, also a definition of signal. Signal is a physical phenomenon whose presence, absence, or variation is considered as representing information. Is this what the vehicle signal specification is doing? Answer yourself. Now we're looking to ISO. Oh, here we find something. Signal is an entity consisting of one or more values and which is part of a logical interface. This is a quite new definition from 2021. If you compare these definitions, you will not find a match. So my recommendation is do not use the term signal for process variable data and process configuration data. That is what we are talking about. This is confusing. And if we are using signal in 20,000 pages from AUTOSAR, and we have also 30,000 pages from CiA, you have several thousands from ISO and IEC, and from all the other organizations, then you are confused at the end because, as we have seen today, there are a lot of different consortia working together with completely total different terms or meaning of terms. Others talking about parameters. Is this better? We can have a look again to the Oxford Learner's Dictionary, what I'm doing always first, because I'm not a native speaker. A parameter is something that decides or limits the way in which something can be done. Is now that what we are called, or what they call the signal? Is this a parameter? Okay, we can look to that and make our own opinion on that. Then we're looking to what IEC is saying. A parameter is a variable that is given a constant value for a specified application and then can denote the application. Still, that's not what we call signal in some things and what we mean when we're talking about some thing what is given by those applications. Let's have a look to what SIE is saying, because J9039, one of the protocols heavily used in commercial vehicles. Parameter is a diagnosable data parameter component, event, or condition. Ooh, now I'm confused. I don't know what parameter means. I have 3 different definitions. Doesn't look that good. So in can physical media attachment sublayer standards like ISO 11898-2, we use parameters to specify the transceiver IC. For example, the voltage range and so on. And this is also something different. So also my recommendation is do not use the term for process variable data and process configuration data. When we discussed this this week earlier in CiA, they said, yes, you're right. The term parameter is not good. But we can't change it. It's already 30 years old. So we use it since 30 years and we have made it wrong. Okay, we agreed. We will still use parameter, but we will not use signal in addition in the same document. Because in the digital annex of the CiA specification, there are 1,000 times signal instead of parameter mentioned. They mix it within one document. And if you look now to the other CiA standards for J939, they have found tons of double use or some of the things where they use signal. And sometimes the term signal is right used because they talk about the wireless signal strength. There's signal, okay. It's a physical thing. We can also look to variable. Maybe this is a better choice. Variable is, according to the Oxford Learner's Dictionary, the number of quantity that can vary or can be varied. Oh, it sounds not that bad, even if this is a generic dictionary. If you're looking to the IEC document, database, you see a process variable expressing the state of a process. Comes very close to that what we like to have. On the ISO online browsing platform, you find for process variable quantity, quality, or condition of a process media or process object, which value may be subject to change and can usually be measured. All these three fits quite good together. So my recommendation is, let's use this process variable or process data, and this could be agreeable things which you can map into a message. Now coming to the models. Models is very nice to have. And Mr. Fox, who was one of the scientists talking a lot about models, he said models are wrong, but some are useful. This statement is very true. We use them and we need them to educate people to have a better understanding on complexity. And we talked a lot about complexity this morning. So because I'm one of the communication guys and I have connected mainframes or developed software for mainframes in the late 70s, so a couple of years ago, there we have had not the open system interconnection model, but similar things. I appreciate that this has been given, and one of the authors is Hubert Zimmermann, a French scientist, software engineer, and this open system interconnection model is a conceptual model. It doesn't mean you can implement that. We will see how complicated this is. It provides a common basis for the coordination of communication standards. This is important to understand. This model is useful for me when I'm writing standards, how to structure, how to partitionating the specifications. It's not for the software engineers. It's not for the protocol stack implementers. It's just for me, for education purposes, as well as for making the right portions for the different specifications. We will see this later. Each layer of this OSI model has its own defined function, and the functions of each layer communicate and interact with the other layers directly above or directly below it, except there is no layer or an empty layer. The OSI model development started in the late 70s. This is when I started my career as an engineer, interconnecting mainframes. And mid of the 80s, it was then internationally standardized or started the project within ISO. And we use, and we are not forced, but we are invited to use this model to describe all communication systems in ISO, independent of this automotive or not. And this gentleman, this is Hubert Zimmermann, and he was one of the fathers, and the other father was from America, and both have written some papers in the early 80s. So it took me time to understand this. And I think most of the engineers are talking about OC model, but they haven't understood it correctly. We have the different layers, and we have the layer N+1 service data unit. This is what you got from the next level, next layer. And the layer N entity adds the layer N header and footer. And then you submit this as the layer N service data unit. On the other way around, when you receive things, you receive a layer N SDU, you remove the header and footer. This is the purpose of this protocol entity, and then you submit the remaining part to the next layer. In the middle, there we have the protocol. And the protocol is the layer N header footer plus the layer N+1 SDU. And this makes then the layer N PDU. And the yellow part, this is called by some people payload. We will come to that where the confusions come sometimes. If we look into the entire OC reference model, which has 7 layers, we see that we have layer 7 to layer 1, and you see very nice that what we have there, the payloads and all the things which I have just described generally for one layer. And in our business, the automotive industry, layer 7 and layer 6 are very often empty, so they have no functionality. So you have a directly mapping from the layer 7 SDU into the layer 4 entity. Already the fathers of the CAN bus in 1991, when they started the ISO standardization, they used such a model, the data link layer and the physical layer, and they have then subdivided the data link layer, because this was coming from IEEE, from Ethernet, so you have the logical link control and you have the medium access control. Describe the functionality for each of these sublayers, and they have also implemented in the CAN chips, in the protocol controller chips, the sublayer for the physical coding. But there was something remaining. This does not fit into the model, the fault confinement and the bus failure management. What's about this? In those days, they didn't know what to do. They just have drawn it on site. You can regard this something like an add-on function, which is not part of the OC model. So smart they were, these guys. In the future documents, in the updated documents for CAN, we have, you see that we have still the same structure as in the beginning. We have now identified the different interfaces between the CAN protocol controller and the transceiver chip. So it fits quite well, and we can describe anything. So you see that we have forgotten the additional functionality. This was not more mentioned. And what we can't describe with this model is an implementation. Let's take the transceiver chips. The transceiver chips may have an optional digital frame hiding or galvanic isolation. They may have additional optional common mode shocks, termination networks, ESD protection, ringing suppression circuit, etc. But this is really implemented in a CAN transceiver chip. You need another model because all models are wrong. You mentioned? You remember? Yeah. So that is why we need a second model for implementers. This is in the annex now in this standard, so that also the implementer can find something. The other model was just for me, to making the correct structure of the documents, and also internally the document structure as well. But this is for somebody who's really implementing this. We need two models, and we should describe the relation of these two models. You have seen that we have the same interfaces where we still have some specifications. Let's have a look to AUTOSAR. When I saw first this, is this a model? I think so, or something like a model. I saw application layer. I was happy because I know, oh, in ISO this is an application layer. Then I was looking for where is in the hell CAN? I found it here, yeah, communication driver. Communication driver is a software which configures the CAN protocol controller. Okay, this is not related somehow to the application layer. This is not the data link layer. What is this? Something aside, I was completely confused on this model. And then there's a microcontroller. I think in the microcontroller there's also the CAN protocol controller, and then but I was lost. And by the way, application layer is, from my understanding, wrong. This is the application, what you mean. The application layer, according to the ISO model, has nothing to do with the application. It's like in human communication. You can compare in human communication the application layer with the rule of grammar. Vocabulary is outside of this. This is in the dictionaries, and this should, I think it should read application. I was looking to another same model with different content from another company. I was looking for something what is related to CAN. You see it on top of that, on the bottom of that. But then I saw also J9039. I was confused. What in the hell is this different modules here? I see the network management, I see the protocol, I see the transport layer. What has this to do with the application layer? I still think the term application layer is misused. And we should adapt this, or minimum we should describe in definitions that this is not the application layer of the OZ model. Otherwise people will throw it away and say, I don't understand. But it's even more complicated. If you, I don't know, who is familiar with CAN? Nobody. Oh, a few, okay. You see that we have talked about that. We have the payload, which is the higher layer, the so-called payload. This is the identifier field and the data field. And then we have the header and footer, which is the start of frame bit, CRC, acknowledge field, and end of frame field. But what is about the white ones? The answer is these fields are used to configure the data link layer entity. They belong to the OZ layer management plane as defined in ISO 7498-4 from 1997. Nobody has, who knows this standard? Nobody is reading this standard. It's there since a long, long time. Close to 20 years. So this was, and if you're looking a little bit more precise to that, then you see that also the parts of the frame format is related to the data link layer header and footer, but only a part. And the same is for the data length code. This is also could be used in some extreme applications for payload. This is not described in the documents. So let's have a look to the new, it's not so new, this is why this is in parentheses, ISO 7498. We have the ISO reference model very well described in ISO 7498-1 from 1994. So was the last release. We see that we have in addition these options to configure and to manage the OSI layers. and sublayers by means of local discrete hard and software interfaces. This is, for example, the CAN driver, what you have written in AUTOSAR. You could make reference to that. It could be also a remote interface that you're using an interface. It could be also the CAN interface. So that means you can configure via CAN the protocol controller. This is possible, and some people are doing so. And we can have this embedded in the SDU, so we can have embedded this in the protocol already, as we have seen. In addition, there's something of the add-on functions. I mentioned them already, the bus failure management, the fault confinement, and we have additional things like cybersecurity, how this fits to the different OZ layers. This is described in 7498-2 from 1998. Also a long time ago, nobody has looked to this specification. It's not quite good specification, should be updated. I agree on that. We have also functional safety as an add-on function, and we have, for example, specifically for CAN, we have a frame fragmentation as well, which we need, which is add-on functions. So if we would structure now our documents in that way and would describe this correctly, then everybody can understand. The model is not that bad. By the way, still have in mind, this is not an implementation model. It's just to understand how to structure a document and to educate people. So if we look into the 3 CAN protocols which are out, this is classical CAN as you know it, and maybe you know also CAN-FD. CAN-XL is quite new and will be introduced in the next version of ISO 11898-1 and 2. This is already on the ballot. And you see that if you're now using this, the OZ data link layer header footer and the OZ data link layer payload and the OZ embedded layer management, then you can describe any of these or identify these different fields in the protocol to these 3 different levels or planes. And this would be helpful that you get a better understanding on your software design also, because then you can reuse this. So just so you see here that we have the data payload for CAN-XL, for example, we have the header, we have the higher layer protocol configuration. Now we can configure, like in Ethernet, we can configure the higher layer protocol as well. And we have the data link layer configuration, and we have the physical layer configuration for the transceiver chips. Anything is well described if you do it in that way, and easy to understand. We try to model this with all the different interfaces, but we are still in the process because most of my members in this working group are still thinking in implementations because they implement things and they don't understand the conceptual model. So we are struggling with that. Main struggle is, from my point of view, is here that they put this into the layer architecture of the OZ model. I would put this on the side, what we have not finalized because we are working on consens. So, and if I'm not in favor of this, then we still discuss. Summary. All standard bodies and industrial consortia aim to deliver high-quality documents when and where the market need them. Quite clear. Both in terms of technical content and easy of use. And we want to make it easy of use, we have to harmonize terminology and we have to harmonize models. These documents are usually used globally and are translated into many languages. Consistency in writing style and tone also allows the user to know how to use them and to have confidence in the quality of their contents. This is very important. We should write our documents not for ourselves. We write them for others. And unfortunately, there are not so many people able to do so because most are engineers and they think in their technologies. They don't think in the easy to understand. Maybe the background which I have as an editor, this is something what I have a benefit. So I propose to harmonize the usage of terms in automotive electronics between international standardization bodies and consortia. And I know we can't change there are tons of documents, but we need then a minimum, and this could be the first step, a database of term definitions and term descriptions or term translation tables for synonymous, respectively homonymous terms. And this is something what I invite all the different participants. With CiA we have quite good an idea to do so, and maybe others will follow this as well. And I propose to develop jointly relation descriptions for different models and to harmonize model terminology. So do not use double use terms, but this is also the topic before. Don't use application layer if it's not an application layer, or a minimum right that I'm using this term differently.
Yeah, thank you, Mr. Zeltwagner, for your presentation.